All right, today we're going to look at parallel lines and proportional parts. And there's actually 5 things we're going to talk about today. And the first one is the triangle proportionality theorem and its converse. Then we're going to talk about the triangle midsegment theorem, proportional parts of parallel lines, and congruent parts of parallel lines. And so we're just going to jump straight in. We're going to first talk about the triangle proportionality theorem. And what this says is you have a triangle and you have another triangle kind of built into that big triangle. So you have 2 similar triangles. And we know that these 2 segments are parallel to each other because they're marked, and also because that's the way this theorem works. You have to have parallel segments. And so if you have this situation here, so if you're given 2 segments or 2 sides of a triangle that are parallel, in this case CD is parallel to BE, then we have sides that are proportional to each other. Then we have AB to CB is equal to AE to ED. Okay, and so what I'm going to do is I'm going to put some variables on here because I think sometimes that makes it a little bit easier. So if I call this X and I call this side Y and I call this side Z and W. I guess I should have started with W, but whatever. So basically, if you have segments that are parallel, and so you've got 2 triangles that are similar because of angle, then you have sides that are proportional. So I could say X is to Y as Z is to W. And sometimes that might be easier to identify than the AB over CB equals AE over ED. So here's an example using the triangle proportionality theorem. It says in triangle PQR, ST is parallel to QR, and they're marked in the picture for us. So now I'm going to mark the sides that they've given me. So PT is 7.5, TQ is 3, SR is 2.5, and we're asked to find PS. So I'm just going to call that X. So because these segments are parallel to each other, I can use the triangle proportionality theorem that says X is to 2.5 as 7.5 is to 3. So now I can cross multiply and divide. So 3 times X is 3X. 2.5 times 7.5 is 18.75. Divide by 3 and you get 6.25. And that's how easy that theorem is. As long as you have sides that are parallel, you can use this theorem. All right, so pause the video and try the your turn. And then you can come back and see if you got the correct answer. So I'm going to use this same picture. I'm going to erase the previous information, and I am going to plug in PS is 12.5, SR is 5, PT is 15, and I'm looking for TQ, so I'm just going to call that X. Set up a proportion. You can say 12.5 is to 5 as 15 is to X. Or you could have started with X and said X over 15 equals 5 over 12.5. Or 15 over X equals 12.5 over 5. It doesn't matter how you set it up as long as your sides are proportional. All right, so when I cross multiply, I get 12.5X equals 75. Divide by 12.5 and you get 6. So hopefully you paused, worked it out, and you got the same answer I did. So that is the triangle proportionality theorem. Next, we're going to look at the converse of this theorem. The converse basically says if you have sides that are proportional, then the segments are parallel. It's just the opposite of the first theorem. All right, so if I have triangle, we'll call this ABC. And then I have ED, it's a segment inside that triangle. And if I know that AE corresponds to EB, and that equals to CD over BD, then I can say that AC is parallel to ED. And so how would they use this? In this next example, they give you side lengths, and you have to determine if those side lengths are proportional to each other, and then that would then tell you your sides are parallel. So in this example, triangle DEH, you have EH, which is 3. So I am going to fill in my information here. EH is 3, HF is 9, GD is 1/3 of GH. So if this is 1/3, and you can just pick some numbers here, you can just say it's 1/3 of GH. We can just say 1/3 of X and call that side X. It doesn't matter. So we want to know, is that enough information, or is that even true information to show that DE is parallel to HG? And so what you can do is you can set up a proportion. 3 to 9 should equal whatever 1/3 X is to X. That cancels, so basically is 3/9 1/3? Yes, because that reduces to 1/3, and they're telling me that is 1/3 of the side. So is EH 1/3 of 9? Yes, it is. They're telling me that this is 1/3 of GF, and it's true. So therefore, yes, they are parallel to each other. Because 3 is 1/3 of 9. All right, so your turn. You can pause this video, and you can give that a go, and you can check your work. So here we go. I'm going to erase the previous information here. Like I just like playing with my little colors down here. All right, so DG is half the length of whatever GF is. And they're telling me that EH is 6 and HF is 10. So basically 6 to 10, is that equal to 1/2? No. So are they parallel? No. It would have to be 6 and 12 in order to equal 1/2. All right, so flip your paper over. Let's talk about the third type of parallel lines transversal parts we have here, and we are going to talk about triangle midsegment theorem. This is one of my favorites. All right, so flip my paper over. Get my editing tools out. I'll do purple because this is my favorite theorem. All right, and so what we have here is a triangle. And I'm going to call this triangle ACE. And I'm going to draw, that's not going to be right. I'm going to draw a midsegment. And what a midsegment is it connects the two midpoints of the two sides of a triangle. So B is a midpoint of AC, and they have to be marked. And AD is the midpoint of ED, has to be marked, or it has to be given in the instructions. So if they don't tell you it's a midsegment, they don't tell you that they are congruent to each other, or something that indicates midpoints, then you don't have a midsegment. All right, so this BD is a midsegment of the triangle ACE. And that's because B and D are midpoints. So they either have to tell you they're midpoints or they have to be marked on the diagram. All right, so because BD is a midsegment, we have what's called the triangle midsegment theorem that says BD is parallel to CE, and 2 times BD equals CE. So that is what the midsegment theorem states. If you have a midsegment, then these two pieces are going to be parallel to each other. And the length of BD is going to be half of the length of CE. So this could be 2x and this could be x. So 2 times the shorter side gives you that longer side. So that's what the midsegment theorem says. So here's an example. In the figure, XY and YZ are midsegments. So what do we know about that? That means ZT is congruent to ZS, YT is congruent to RY, because they're telling me that these pieces are midsegments, and XR is congruent to RS. And we also know that the length of XY is going to be half the length of ST, and XZ is going to be half the length of RT. So that's the information that we have because of a midsegment. But I don't need all those extra markings in there right now. So we need to find the length of YZ. So here's YZ. It is parallel to RT. RT has a length of 13. So what is the half of 13? Because by the definition of the mid-segment triangle theorem, those pieces are going to be half of each other. So half of 13 is 6.5. Okay, and now we're going to come over here and look at, get rid of all those markings. Now we want to find ST. Well, ST is this segment here, and it's parallel to that segment, which is 7. And 7 is going to be half of ST. So what is 7 doubled? 14. Very good. All right, now we're looking for the measure of angle RYZ. No, RYX. Hello. RYX. We're looking for this angle here. Well, if YZ, no, that's not YZ, that's XZ. I'm telling you, my letters, it's hard to tell sometimes, my alphabet. All right, so XZ is parallel to RT. And we're looking for this angle RYX, and they've given me this angle 24. What do we know about those two angles? If you said it makes the letter Z, you're absolutely correct. So I have that letter Z because I have parallel segments. I'm allowed to talk about Z. Then I know that those two angles are congruent to each other. So this angle is also 124 degrees. Pretty cool. Okay, so recap, we had a letter Z because of parallel segments. And so those two angles are congruent to each other. The angle I'm looking for and the given 124. All right, so your turn. Pause the video and give that one a try, and then come back and check your work. It says to find the measure of each of the following. So I'm looking for the measurement of DE. DE is parallel to AC, which is 15. Half of 15 is 7.5. Did you get it right? Good. Now we're looking for DB. DB is parallel to FE. Well, this is going to be whatever 9.2 is doubled, 18.4, but I don't want 18.4. I only want half of that because I'm going from the midpoint to the other endpoint, so it's also 9.2. Did you get that one correct? Good job if you did. And then let me erase all that junk. Now let's take a look at FED. Angle FED is this angle here, and it is congruent to this angle 82 because of the letter Z. So it's also 82 degrees. Did you get them right? So look for the Z's because of parallel lines. We have those Z's. Those are alternate interior angles and they are congruent. And then just know that the half of the length of that opposite parallel side gives you your mid-segment length. All right, next, proportional parts of parallel lines. And so what we have here is a beautiful picture of 2 transversals and 3 parallel lines. And so I'm going to mark these parallel with the extra arrows on them like that. And so now I've got 3 lines, 2 transversals, and those 3 lines are parallel because they're marked. And instead of making this confusing with letters, like points, I'm going to use some key indicators. We'll call X this segment, Y, Z, and W. So if you have this situation where you have 3 lines that are parallel and 2 transversals, you have a proportion. And the proportion is X is to Y as Z is to W. And it's that easy. You plug in your numbers and your missing variable and you cross multiply and divide. So here is an example. Frontage is the measurement of a property's boundary that runs along the side of a particular feature, such as a street, lake, ocean, or river. Find the ocean frontage for lot A to the nearest tenth of a yard. So I am looking for this segment here. I'm going to call X. And if you notice, I have these parallel markings. So that tells me that these are parallel, and I have my transversal and my other transversal. So this is proportional parts of parallel lines that we just talked about. Of course it is because it's in that section. So I can set up a proportion. So I need to know the frontage for lot A. I know the frontage for lot B is 60. And then I've got 58 yards for lot A, 42 yards for lot B against the road. So it's very visual. You can definitely see the proportion there. So you would cross multiply and divide by 42. and you get to the nearest tenth of a yard, 82.9. Super simple, just set up a proportion there. All right, the next and the last type of problem we're going to look at is congruent parts of parallel lines. So if you would, just flip your paper over. Remember, if I'm moving too fast, you can always pause the video, rewind the video, and look back at the video. Let's do Green Shore. That kind of got cut off there, but that says congruent parts of parallel lines. And so we're going to look at another picture. So this time I have parallel lines. Again, two transversals again. I'm going to make sure that you know that these are parallel by the extra arrows here. All right. So I'm going to put some key indicators on here so that way it's a little bit easier to identify. Of course, we know that those pieces are congruent because it does say congruent parts of parallel lines. So this is the given information, what I have. And so I am going to say I've got X, Y, Z, and W again. So we can then conclude if X and Y are equal, that Z is equal to W. We won't need to set up a proportion like we did before because those pieces are congruent. It wouldn't matter if you forgot and you'd set up a proportion because you'll end up getting the same value. So here's an example. I've got my parallel segments. Okay, they're marked with the little extra arrows. And I've got these tick marks that indicate that my Y values are going to be, those sections are going to be congruent to each other. Not that my Y values are congruent, but 3Y plus 8 is congruent to 5Y minus 7. Tired, boys and girls, I'm very tired. All right, so I am going to find X and I'm going to find Y. I don't care who you find first, but because these pieces are equal to each other, the congruent parts of parallel lines then says these two pieces are equal to each other. Isn't that cool? Super easy. So all I have to do is set them equal to each other and solve. So 6x minus 5 is going to equal 4x plus 3 because of congruent parts of parallel lines. Subtract 4x, I get 2x minus 5 equals 3. Add 5 gives me 8. Divide by 2, I get 4 for my x. My y's, they're marked congruent, so I can write my equation. 5y minus 7 equals 3y plus 8. I'm going to subtract 3, and I get 2y minus 7 equals 8. I'm going to add 7, and that gives me 15. Divide by 2, and you get 7.5. So if you have these markings, big if these are marked, then we can conclude the other sides are also congruent. All right, your turn. Pause the video, give it a go, and see what you come up with. And there's two problems there. All right, so if you notice, the 8s are congruent to each other. So we can now say that these two are congruent to each other. So my equation would be 7x minus 2 equals 4x plus 3. Hopefully that's what you did. Subtract 4 and you get 3x. Add 2 and you get 5. Divide by 3 and you get 5/3. So did you get it right? Good job. Part B, if you notice I have my tick marks indicating congruence, and so therefore 2x plus 1 would also be congruent to 3x minus 5. So I can set up an equation and then I can solve it. I'm going to subtract 2 from my 3x because I like a positive x value. And then I'm going to add 5 to 1 and I get out of there. I don't want you. Try to get it to go away. There it goes. Add 5 to 1 and I get 6. So x equals 6. And that is the 5 different theorems and rules that we have for parallel lines and proportional parts. So down here at the bottom, I'm just going to do a quick summary for you because I feel like that was a lot. So quick summary, you have a triangle and we know that those two sides are parallel to each other. I'm just going to put some variables in here. So because I have some parallel sides, I can set up a proportion. This would also make a great note card. So that's one rule. And then I have another rule that's the opposite of this one. I don't know I have parallel sides. So if, let me put the right letters here, if xy is equal to z over w, then we have parallel segments. And I'll mark that in red. Then we have parallel segments. That's just the converse of the first theorem. They're just the opposite of each other. All right, the other thing that we looked at was, let me flip through, triangle midsegment. So if you have a triangle and you have a midpoint and a midpoint, and each triangle, by the way, has 3 midsegments to it, but we only usually work with 1 at a time, sometimes 2 at a time. So if I have this situation here, then I know that I have parallel, and I know that this is x and this is 2x. So if that was 5, the midsegment's 5, then the side opposite would be 10, so forth and so on. So that's the midsegment of a triangle. All right, then we have proportional parts of parallel lines. Say I have this situation here. Those 3 lines are parallel, and I have a proportion. I could say x over y equals z over w. And the last one we talked about is if those 3 lines are equal distance from each other, then we know that x and y are equal to each other. So there's a nice little summary of the 5 rules. So copy that, study it, make a note card for it. Fantastic little rules that you can use as long as you have parallel lines. If you don't have any parallel lines, then these do not apply. All right, good luck on your classwork. Let me know if you have any questions. Make sure you take a picture of it and upload it for me in Google Classroom. See you guys later.